Okay. So yeah, first of all, thanks for all coming. I'm going to share my screen so you guys can see what I see. First things first is IDT 2021. This is our page. This is the classwork page. It's really, I don't know how our teachers set it up. I always set it up so it's easy to see what to do and what you need to do, because this is kind of like a continuum. It's really like annoying. But if you go to classwork, then in here it's kind of structured, right? Where these are random tasks that we have up here or information. And then down here is design for play. So we have learning guide and your project slides. You never have to turn this one in. This one here technically is not due until like the end of the term. Learning guide 2 though has a due date, and so does this isometric practice task that we'll be going to. So we're going to learning guide 2. Welcome to jump in this as well if you want, or you can just watch as I go through it. On here, learning guide 2, week 5, which we are now, Friday, which is the 5th. Learning intentions. So having watched the Tales of Creativity and Play, and playing Cass Holman's Design for Play, we've learned a little more about what it means to design for play. So what does it mean for design for play? As you would have had for your notes, create an atmosphere for play to propagate. Challenges result in rewards. Freedom and choice are very key, and questioning your curiosity. So that means like you're curious as to why something happens some way, which causes you to learn more, and like the snowball continues. The next step will require you to personalize and finalize your design brief, followed by your first wave of ideation. So in the previous learning guide in here, we have the research, which you guys should have done. So that was due in class, right? As I mentioned, this research here, where it meant to take you about 2 hours. You define 10 images you can use some from examples from here, and you answer these questions about each of them. Right, so that was the first task to do. That should be on your slides. It can take up multiple slides. If you duplicate and add slides, it's fine. Or it can just take up once, or it will definitely take up a few slides, I presume. This is last week's homework, right? Work now homework if you haven't completed this. So please make sure you get this done. This is key. You need to get this done. And also it will help you with the design process. We don't make you do research for no reason. It is literally there to help you. You want to do this for your own sake. And then, so we're moving on to doing our design brief, and then we'll be doing our first wave of ideation. This will begin with a session learning and practicing isometric skills, so sketching, followed by an activity requiring you to improve a selection of research existing outcomes in 10 different ways. So the next task, this learning guide is going to require you to use the research you did in the previous learning guide, right? So if you don't have that research done, then you can't do this one, etc., etc. Remember, everything you do needs to be evident, so don't throw anything away. The norms, Kia, because we're doing a bit more research. Pukeko, because you're going to be creating things now. You're going to be doing some sketching of your own. And Pungawedawedi to utilize, because you'll be using skills from a range of different disciplines. Design brief, this is what we need to get done. Is a conceptual statement, situation, and list of specifications which state the requirements you must meet. Ideation is a quick conversion of thought to sketch for new ideas. So ideation is kind of like, you might have heard it before, like sketching out ideas or making concepts. Ideation is like the very quick stage of going from what you have up in here, like in your head, like you think of an idea, and then putting that idea down instantly. Kind of like those tasks that we ran in class where you had to mix, I don't know, a banana and a football, or where you had to draw the person sitting next to you, or whatever like that. It's like really quick, or a circles challenge. Really quick kind of ideas into visual form. And then we're going to be learning isometric drawing. Now, isometric drawing, for some of you, this is going to be easy. Like, man, this is easy mode. I did this in kindergarten. This is so old. Some of you, this might be like, I have no idea what isometric drawing is. So there's going to be a big range. The activity to start with is really simple. So if you're really good at it, then just knock this simple activity out, and like you could do it in 5 minutes you could do it in 5 minutes quite easily, and then you're done for this, okay? If you're new to this, then there's a few different resources here to help you. An isometric drawing is a 3D representation of an object, building, or design on a 2D surface, aka your paper. So it's a 3D, it's making you guys draw in 3D rather than draw in 2D. One of the defining characteristics of isometric drawing compared to the other types of 3D representation is that the final image is not distorted. The word isometric comes from the Greek to mean equal measure. What this means is that when you, I might have explained this to you guys before, when you look at anything in real life, you have, if it's interior, everything goes to a singular point, vanishing point. If it's anything outside of a building, or if you're looking at an item, everything has two vanishing points. That means your eyes are on either side, and that everything kind of shoots off. The object is largest when it is closest to you, right? And then it shoots off and gets smaller the further the object gets away from your eyes. So you have something really small, like a phone or something. You can't really tell this because it's so close and it's so tiny. But if you would have like a larger object, the bigger the object is, the faster, and depending on this kind of scale you're working with, will determine how small it gets. Isometric does not do this. Isometric is very simple and all sides are the same length. I'll go into this in more detail soon. So yeah, so that's what those mean. We scroll down. This is the design brief here. So what you need to do is you need to copy and paste this design brief into your Google Slides. So if we look back here, if we go to your Google Slides, this is yours here. You should have your name on the first slide, right? This is your notes from watching those TV episodes. And then there's your existing outcomes. There's 2 pages here for you. You might need to make more. And then on the 5th page, or however many pages you have, this is your design brief. And this is what you need to fill in. So we've done it mostly for you. There's just a couple of things you need to change yourself. So first thing is anything that is written in italics and is colored, that means that you have to replace that with what you want to write in there. So these things need to be replaced, okay? So you'll need to, you're going to design, I guess in here, you can design, you can either choose, I guess, if you want to design like a object or multiple objects for play. It's probably always going to be multiple objects given like the way we're thinking about this. So you could just take out that line, that's fine. That is suitable for, I mean, right the age range of kids. So for this one, you can choose. I'd say you'd kind of want to be going for young, right? Not too young, they don't really know what they're doing, but I mean, relatively young. That we have the primary school over there, and we have the junior college as well. So that would be pretty cool. You could do it for like kids from like 5 to 8. I want to go probably any older than 10. Maybe you could do a little bit, but somewhere between that, 5 and 10. But you might want to specialize that even a little bit more, right? So that it is between like 5 and 8 or 8 and 10. Or maybe 8 and 12, something like that. So you get to choose who you want to design it for. Obviously, depending on which age of kids you design for, will result in different kind of designs, right? Because some are going to be more simple. Some might have little smaller pieces. Some might have parts that can break really easy if kids are too like rough with them. Some designs might be too simple and easy, so kids will get bored. So there's not any challenge for the older kids, etc., etc. The objects is intended to provide a space for children to, I mean, in here, you need to think about like a word that you want children to, what you want your object to do. So collaborate is meaning the purpose of your design is for students to work together, right? To collaborate. Maybe you want to have one in there for children to, maybe it's like an experiment one, or maybe the purpose of it is a space for children to create, so that they can like build their own kind of thing. Maybe it is there for students to, or for kids to provide a space for children to What else is there? I'm not sure. Try and think of words that you like, the main purpose you want your design to have. Is it for them to work together? Is it for them to like experiment? Is it for them to like build something? Is it for or is it for them to kind of like create something, like an outcome, like so that you can keep and is separate of what you've made? Yeah, there's a few there. So I guess think about what is this whole purpose? Is it literally just to have fun? It might be a little bit vague because it all should be fun, right? So it's all there for play. So yeah, try and think of what kind of the object is intended for the children to do. Then we go down. What's it trying to encourage, right? So this is your conceptual statement. So this is going to say what it is. So maybe like I'm going to design objects for play that is suitable for 5 to 6 year olds or for really young children. The objects are intended to provide a space for children to. I mean, I want to put in here like build as an example because I want to design something where the students can get the different pieces and they kind of create something new, and then from that they play with that, and then the next day they can break it down and build something up again. So that's what I want. That's what I want children to. I want to encourage students down here. That my object is going to encourage children to like build something amongst the users, right? Next thing is we want to take into account ergonomics and human factors. Ergonomics means that how an object relates to a human, so a person. So like this drink bottle is an example, but to think about ergonomics for this in the sense that it's nice and smooth so I don't cut my hands, that it has like a lid so it doesn't spill, that it's not too heavy, that it can hold a decent amount of water, that the glass is nice and solid so it doesn't break if I drop it, etc., etc. So how items relate to people and human factors and appropriate for the age of kids, so what you read up above. The item needs to be durable and withstand wear and tear. Durable meaning, like I said, strength over a long period of time. And then we have down the bottom here, include your own extra 2 special specifications. So these are you to write 2 more things in here about what you want specific to your design. Like, do you want it to be modular? So modular meaning like you can add things to it. You can like have like expansion packs, if you know what I mean. So it allows for every tool to be used in a different kind of way. Do you want it to? What else is what kind of a specific item would you want for a toy? Would you want it to be of like a certain size, perhaps, or would you want it to be made out of a particular material? Would you want it to only be made of like soft kind of shapes, so there's no like sharp edges on it? Would you want it to require 2 hands to use, or would you want to like maybe be like a 1 person? Would it be would you want it to be made for like multiple people have to use this to be able to build it? I'm not too sure. You tell me. So you think of like a couple of 1 or 2 specifications, extra ones that you want to have specific to your toy. I mean, not your toy, sorry, your object for play. That way, your design brief, it's going to be different compared to Sally's, compared to Billy Bob's, to everyone's. You're all going to have like a unique one. And so this is the design brief, right? So this should take not long at all, 10 minutes, 15 minutes maximum, just to replace these words and then write in your own specifications. Going back to the going back to the learning guide. So on here, if we scroll down, so that's just this section here, get this done. And then we go into isometric drawing. So throughout the design process, there are times when you need to communicate your ideas in a visual form. Sometimes a quick 2D sketch is enough. Other times a more detailed drawing is required to really convey what you are thinking. A common technique to showcase your ideas in 3D is isometric projection. It presents your idea in 3 dimensions, so the top, side, and front, and structures the form to help assist with proportion and scale. The following images, these images here, gives us an explanation and video clip of a drawing technique and how to convert any item, pre-existing or new, into isometric form. So this is a step-by-step guide for making it create an isometric. It goes through basically we want a baseline and a vertical line. From this, you want to do 45-degree lines out from the center point. You want to create a second vertical line on here, and then create a second 45-degree angle. So it gives you like an edge, a side, a front. This will give you your other side. Finish off the base with another vertical line. Vertical line, this is your base complete with 4 vertical lines. And then you fill in the top of the rectangle. And then this is like an example here of the front, side, and top done. So this is like a quick step-by-step how to do an isometric, say, Lego block, like an isometric rectangle. If you go to a video clip, it's like a 15-minute video clip of me going through, showing you guys with an example of a box, going through, drawing this up, right? So I explain what it's all about, and then I go through an example of how to draw the crate. So you can watch this back as many times as you want. Now we go from... And this is just to create like a crate, and then from that, it will push out to create like another crate expanding from it. And it kind of shows you if you want to add one above. And if you start getting like a circular kind of one, you can add on as well. So this image here kind of shows it is 1, 2, 3, 4, kind of the fourth one of an arc to it of like Lego bricks kind of being stacked up upon one another. So this video, quick step-by-step, is into how to do isometric projection. Same thing can be done, seen on these images here as well. And so the first task is you have, using the video and step-by-step instructions above, draw the following 3 Lego bricks formations in isometric. Upload these to a separate task in Google Classroom. So this should take you about 1 hour. Now you can see that these images are like how they are here. Your task is to draw these in isometric, not to draw these as you see them. So I can tell that when you upload this into Classroom, I need to be able to see your crating, guys, which means I need to be able to see your working out. If you just draw these images as you see them on here, I can be able to tell from whether or not your lines are parallel, so whether they're straight with one another, what kind of angles you're using. I need to be able to see all your working out. If you just draw them as they are, then you're not going to be learning the technique. And then as soon as we go to drawing something more difficult, because this is as simple as you can get for isometric items, then you're going to really struggle, right? So please make sure you like apply this sort of logic here about always starting with a baseline, always starting with like a center vertical line, and then from there you can go out your 45-degree angles and you can build up what you need to be doing on this. Yeah, that's kind of, you're here to learn the technique. It's like doing maths, and you don't learn the equation, you just can answer the question. Like you can answer simple questions, but only because it's like doing times tables, and it's like 6 times 6, and the only way you know the answer to 6 times 6 is by going 6 plus 6 plus 6 plus 6 all the way up until you get to 36. But like in a simple way of doing it, maybe plus 1 all the way out. So you don't really understand like the equation behind it or how to get there quickly or how to multiply. You're just using addition to get 6 times 6, right? That's not what we want to do. We want to be learning the technique behind this. And the video here goes through that. It explains that. So that's the first activity is do this. That is found on Google Classroom. So in here, we have the isometric practice task. This is due tomorrow, 1 p.m. So this is due before our next IDT class. Upload your 3 drawings of Lego formations here, due 1 p.m. tomorrow. So just grab a piece of paper, grab a pen or pencil, draw up those items, those bricks in isometric, and then you're done for that first task. Below that, the main task is using your newfound power of isometric projection from your first task is to start choosing one of your existing outcomes. So that means one of your research from here. Pick one of these things that you researched in here. And think of 2 ways you could improve it by asking yourself a what-if question. E.g., as an example, what if it was stretched so more children could play with it? What if it was made from flexible materials? Sketch your 2 improved ideas for each existing outcome in the isometric. Next, choose 4 more existing outcomes and improve them in 2 different ways until you have 10 different ideas in total. Remember, this task is about practicing your sketching skills and how to think like a designer. Look back at your analysis, highlight what the existing outcomes limitations are, and come up with new exciting ways to add value. And these are examples here. So this is Lego bricks, right? This is a Lego brick. And then so the first question was, what if Lego was giant? And so this one is literally making Lego like a lot larger. This is blowing it up and making that huge. And that's going to make it into a different kind of toy altogether, right? What if Lego wasn't straight and so it was curvy? And so Lego bricks now are all circular or wavy or have like these big curves to it. As you can see on these examples here, you can see that is crating on here. So this has got crating. You can see there's like some light pencil lines going around this. Maybe you need to bright screen brightness up. Crating going on with this one up here as well. So both of these have like lines going around them to show this is how you keep them in proportion, to show that how they work, right? Same with this one down here. Number 2. Oh, not that one. This one. The balance board. This is using isometric, guys. Isometric, you can see this is the vertical line. This is the 45-degree line coming out the side above the word balance, coming out to the left-hand side, creates a base, and then it raises up all 4 corners, and then there's like a top section to it. And then so the example's got a top cut off, so you get the correct height for the board. And so this curvy drawing is done in isometric. This is an isometric drawing. Same for the 2 down here. So this example is showing what if this is like the balance board. What if the balance board was off balance? So it was actually on one side, it was like this. So maybe this could be used as like a chair, or you could roll, or loads of different kind of ways to use it if they changed that. What if the balance boards could join together? So there's like an idea where you could improve them by perhaps the fact that they could like click in together and make a bigger example. And then we have down here, these like these stacking, what is it called? These Snegno building blocks, and the example down here is what if they were all blobs, so rather than being like sharp-edged items like this one here, this is all like sharp-edged blocks, right? And you stack them up. Rather than having them that, they had them all circular and wavy blocks instead. What if that was an option? Well, this one, what about if they were like, they could be connected, so you can make like different kind of shapes that would like defy gravity more. So these are 3 examples here. One is Lego, 2 different changes. One is the balance board, 2 different changes. One is the balance bricks, 2 different changes. So that's the next task after that. And this is what you have. This is what you have all week to do, right? So you got plenty of time. First things first, jump on to your slides. Check that you've got the research done. That has been homework for the last week. Finish write up your design brief. It should take 10 minutes or so, maybe a little longer. And then after that, make a new Google Doc. Draw up, or you don't have to make a Google Doc, or you do make a Google Doc for this one. Oh, no, you don't need to actually. You just draw it up. Get some paper. Do the practice task. Practice task upload into isometric practice task. So in here, right? And then after that, start improving 5 designs in 2 different ways for each one. This is an example 3. Please don't use these examples. It's just showing you, demonstrating you what you need to do. Any questions? Up to Mr. What's up, Any other questions? Lockdown's okay. I'm in at school because I don't have any internet at home. That's just the way it is. So if you guys have questions, just contact me. And then from that, yeah, I can reply. You can email me or you can contact me on the Google Classroom. Like I mentioned, things to hand in is just that isometric, the design brief on your slides. I can check your slides at any point. Or research, design brief, isometric task, and then the improving of 2 designs. I'll leave now just so you guys have time to work on this, start working on this lesson. Thank you all for coming. We won't be having a Google Meet tomorrow, but no. I'll let you know today if we're having a Google Meet tomorrow. It's yet to decide. But that isometric task is due tomorrow before we have if we have a Google Meet. It's just due tomorrow by 1 o'clock, either way. Great. All right. Well, that's all. Thanks for coming, everyone.